Hi, fifth grade. All right, yesterday we learned about two types of blood cells that are in our blood. The first one were these little soldiers that get sent out whenever there's some sort of disease or infection or bacteria going on in your body. What were those called again? Not red, but white blood cells. And remember, there's all types of white blood cells that are in your body. Some of them sound the alarm that there's some sort of thing in your body that shouldn't be there. Some are like the SWAT teams of white blood cells that go out and they actually attack what needs to be attacked. And then we have our platelets that, remember, the platelets' job is to go and to repair damaged blood vessels. So like if we have a scab or a cut on our arm, they'll go to that spot and they will begin to fix that that area with the covering, and they will put the fibrin in there and allow the scab to grow so that new skin can grow. Now remember, we talked about 3 parts of our immune system, because our white blood cells are a part of our immune system, but they're not the only part. There were 3 parts. There were the skin, our lymph nodes. So like if we have a sore throat, you can feel the bumps here because that's where all the white blood cells go. Those lymph nodes kind of filter and trap those bacteria and diseases in those sections, and then the white blood cells go there and attack it and try and kill whatever's going on. And then so our white blood cells, our skin, and our lymph nodes are the 3 things that make up our immune system. So picture this: if you didn't have your skin, imagine what would happen. So people who get burned are very, very susceptible, or have higher chances of getting sick because nothing is blocking bacteria or germs or something from getting inside your body. So your skin is kind of like your first line of defense. So when someone gets a really bad cut and bacteria and germs can get in, it can lead to bigger problems like amputations. Remember I told you the story about when I cut my leg and it almost led to an amputation because I had a disease in my leg that shouldn't have been there, and it all came because of a cut. Now, normally your skin kind of blocks that. So again, those are what we learned about yesterday. Today we're going to learn about the types of blood that are out there. There's 4 types that we're going to be looking at, and then we're also going to be looking at blood donation, and how hospitals and modern medicine have been able to take blood and store it for future use. So those are what we are going to look at. For many years, people have tried to transfer blood from a healthy person to a sick or injured person. And sometimes that transfer helped patients, but a lot of times it actually made the patient's condition get worse, sometimes ending in death. When we transfer blood from one person to another, we call that a blood transfusion. Again, blood transfusion is transferring blood from a healthy person to a sick or injured person. When they first started trying this, again, sometimes it helped people, but a lot of times it just made someone worse. Well, why is that? It wasn't until 1901 when this handsome fellow right here, Karl Landsteiner, he was an Austrian physician, he discovered why blood transfusions didn't always work. He found that blood is not the same. Instead, there are different types of blood. So, only certain types of blood can go in certain people. When you were born, you have blood that is the type from your parents. And if you were to ever get sick, there are some types of blood that will help you and other types that your body won't recognize, and it'll actually make you sicker. So let's learn about these 4 types of blood. So we know that there are 4 main types that we can look at. We also know that some types cannot be successfully mixed with another type. So a person who gives blood, they're called a blood donor. They donate their blood. And a person who receives a blood transfusion is called a blood receiver. Now that makes sense, right? So here are the 4 types of blood that we're going to look at. We have type A, type B, type AB, and type O. Now, what do you notice about those 4 things? Well, let's look at this. In our type A, what is sticking out of them. Now, this isn't really what it looks like inside. This is just so you can understand the differences in them and how some mix and some don't. That's right. Blood type A has like these triangle shapes, and blood type B has these circle shapes. Two different types of blood. We also have a third type that has a mix of what? Yeah, it has a mix of both of them, A and B. Okay? And then we have type O. Does it have anything on it? No, and there's something that's good about that and something that's bad about that. All right, let's keep going. So, the main blood types, again, are A, B, AB, and O. This is the percentage of each of these types in the U.S. Which one is the most? Yeah, type O is the most common type of blood that you're going to find in the U.S. And then we have type A, that is second, and then type B is third, and there's not really a lot, but then look at this one, type AB, there's only 4% of the population in the U.S. that is actually that type of blood. Now, what problems do you think that could bring up when it comes to people? We'll talk about it in a second. So these names identify a special protein that's found in the red blood cell. Now, some people have only the A protein, other people only have the B protein, and other people have both of those proteins, and some have neither of those proteins, okay? O would be neither of those. A is a certain type of protein, B is a certain type of protein, and AB has both of these proteins in them. So if a person with type A receives type B blood, the white blood cells, remember those soldiers that if there's something that enters your body that the soldiers are like, those shouldn't be here, they will go and attack. Well, if type A blood receives type B blood, those white blood cells in A identify these B proteins right here as enemies. And in trying to get rid of the enemy, the white blood cells cause the red blood cells to clump together and clog up. It clogs the blood vessels, which doesn't help the patient. That actually could cause blood clots and go to the lung or cause a stroke or cause some major issues there. So it's the white blood cells that go after that blood that's being put in that shouldn't be there. So since type O blood doesn't have either type of protein, it can safely mix with any other type of blood. Isn't that kind of cool how type O was the one blood that is mostly in people? The highest population in the U.S. are people that have type O, okay? So it can mix safely with any other type of blood. So people that are type O blood, we're called universal donors. It means that we can donate to anyone because there are no proteins attached to it. Therefore, the white blood cells don't know better. They're like, oh yeah, okay, more red blood cells, more blood, come on in. Those with type AB blood, though, they're called universal receivers, okay? They can't donate to just about to many people, but because they have both A proteins and B proteins, they can safely receive any other type of blood because their white blood cells wouldn't know better, okay? So O, universal donors, type AB, universal receivers. Now, blood transfusions have saved many lives. Blood is often needed for people who have been in accidents or having surgery, and if other healthy people did not donate some of their blood, these blood transfusions would not be possible. Now, believe it or not, only 10% of people who can actually donate blood. The other 90% don't do it. But think of all the people who benefit from blood transfusions. You can't save people's lives who have lost blood if there's no blood to receive, right? So think of it this way. Blood donation, if you are a healthy person, you can donate blood every 56 days. And you donate about 450 milliliters of blood. All right. Now, there are some rules to donate blood, so don't sit there feeling like, oh, I don't do any of this. Well, you can't, okay? Usually to donate blood, a person has to be at least 17 years old. So you guys have several years to go before you even qualify to do that. You have to be healthy. You can't have any diseases. You can't be sick. And you have to weigh at least 110 pounds to safely donate blood. Then a person can donate blood. Our body, we know, as we've learned before, can make more blood cells to replace the ones that we've donated. So remember that we have in our bone marrow, if we create more red blood cells to replace ones that have been lost, and we can safely have the right amount in our bodies every 56 days. Now, after blood is donated, it's tested to determine the blood type. Is it O? Is it A? Is it AB? Or is it A or is it B? The blood is often separated into parts, and I think this picture is really cool because you can actually see the many different the parts that we've been talking about. This top part here, this is the plasma. Remember we talked about the plasma is that yellowish liquid that's mostly made up of water. It can actually break down the proteins that need to be in nutrients that are brought to different parts of the body. This is like the highway system for our blood. So here's our plasma. Then what is all this red stuff down here? Yeah, it's our red blood cells. That makes sense, right? And then this stuff right here, this is a mixture of our white blood cells and our platelets mixed in there. So you can actually see how they get separated. Well, how is it that we separate that blood? There's a machine right here called a centrifuge. And it basically means that they put blood in these vials and it's all just one red liquid. They put it in this machine and it starts to spin really fast. And it spins round, round, round really fast. Well, things that are more dense flow to the bottom, and things that are less dense flow to the top. So, of this right here, what is the most dense part of our blood? Yeah, it's our red blood cells. And what's the least dense? Our plasma is. Very good. So, there are several, this way, when we separate blood like that, this allows for a couple of different things. It allows for several patients to use different parts of the same unit of donated blood. The blood is stored in a blood bank, something like this, until someone needs it. Now, most donated blood can be stored for only a short time before it's no longer useful. That is why blood donors are always needed. I can't take that blood and just put it in a freezer and hope that it could stay there for the longest time. In fact, I'll read these statistics to you. 1 unit of blood, one of those little IV units of blood is equal to about, again, 450 milliliters. And once it gets separated into different parts, our red blood cells, our white blood cells and platelets, and then our plasma at the top, each of those things can live or be useful for only a certain amount of time. For instance, our red blood cells, they can be safely stored for 42 days before we have to get rid of them. Platelets only last for about 5 days, and then they die as well. Plasma can safely be stored for about a year if it's frozen.